So let's get started. Yeah, like pretty much Linda has explained all about me. And apart from all this technical side, like I like photography, traveling. And during the pandemic, I've started learning crocheting also. So that is also that's something which I do. Again, about this paper, this mainly discusses like since I'm mainly doing performance testing, I've tried to see where are the possibilities, like wherever we can enhance the software performance testing with the help of AI. So how I wanted to talk about is like we'll just talk a high level about AI and the machine learning concepts. Then we'll understand like what is software performance testing and what is software performance engineering, how they are different. Then we'll see some of the use cases where I feel AI can help. And consider this as like a food for thought for your mind, and all your right minds can go out and explore and read more. It's just based on my experiences and my learning skills I've come up with this. So, yeah, it's a picture from the internet. So yeah. You would have always like seen like various kind of formations, like maybe in a Venn diagram and like various kind of things you would have seen this. So the major umbrella is like the artificial intelligence, and then comes machine learning, which is a subset, deep learning, and then generative AI, which we have been hearing a lot for the past 2 years. Let's understand each of them. So what is artificial intelligence? Artificial intelligence is nothing but a technology that enables computers or any machines to simulate human intelligence, or basically like whatever human can do, if it can think or like do like that way. That's what we are trying to say with name artificial intelligence. And today there are like a lot of technologies which are using artificial intelligence, like computer vision, speech recognition, and so on. Then comes machine learning. What is machine learning? Because at times we are confused, like we are hearing so many things. How is it different? So machine learning is a field of study in the artificial intelligence, and it is concerned mainly with the development and study of the statistical algorithm. So that's why they say if you're doing machine learning, you need to be aware of a bit more of the statistics and like those kind of things. So here what we can do is it learns from a lot of data, huge amount of data. And based on that learning, it can create models, and we can use those models to predict or to generalize on unseen data. So that's the main thing about machine learning. Again, in machine learning, there are like various types of algorithms. You would have heard about linear regression, then like things like decision trees. Then there are like ensemble models where I use more than one models and come up with different models like bagging, boosting, all those things. Then comes deep learning. Deep learning is again a subset of the machine learning. And here, rather than just the statistical models, we use neural networks. It's like how the brain is working. So many neurons are connected. And there we have like various nodes. You have a set of input nodes. Then you have a set of, sorry, one set of input nodes, a set of hidden layers in between, and then a set of output nodes. And there are so many functions, which functions and usages, which helps in coming up with the output set of data. Then generative AI, that is something which, okay, in the deep learning is what you hear about, like convolutional neural networks, all those things you would have heard about. And the major uses comes in again, natural language processing, all those stuff. Then generative AI is a subset of deep learning. And here what it does is it uses this neural networks, and it studies the data, identify the patterns and structures, and it generates new data based on the existing data and the patterns it has learned. So, you would have heard about like various generative AI models, like ChatGPT is there, which is from OpenAI, which is using various GPT-4 and various models. Then they have like the image generation model, which is Dolly 3, that is again from OpenAI. Then Google has, like Meta has, Amazon has the Titan models. So all those are the various generative AI models. And those are called the foundational models also. Sometimes you hear foundation models also. So now comes the software performance testing. I don't know like how many of you are aware of the performance testing, because most of the times when you talk to other people, they know about automation testing or like warehouse testing or things, but performance is something which I haven't heard like many talking about. Yeah, even after coming here, I have met only some one or two people who have done performance. So let's see what is performance testing. Okay, first we'll understand what is software testing. Software testing is an empirical technical investigation conducted to provide information about the quality of product or service under test. Okay, it's a definition, but let's see what it is. Basically, you can't just think and say, oh, maybe it will work like that. No, you have to do something and show us a result and say, because that's what they mean by empirical. You need to show some evidence that, okay, I tested this and this is how it is expected to work. I think that this will work like that. It doesn't work in software testing. You need to do some testing and show a result. Then there are like various types of testing and various types of definite like what is it? Based on different criteria, you can divide the software testing into various types. And here I'm interested more on the manual and the automation testing types. So as you know, like automation testing involves the usage of tools or techniques, and manual is more like a person or like a person is doing the testing based on the test cases or flows. Again, the automation testing, it can be divided into two, functional and non-functional. Functional, as the name suggests, it's like using some tools or technologies, you are testing the functionality of that application. Let's say you have a login screen. Using some automation, you are ensuring that, okay, you're providing the username and password and logging in properly. If you are giving a wrong one, it's not logging in. That's the functionality. Then comes the non-functional part of it. So performance testing, security testing, usability testing, all these are the non-functional testing. What does they do? They are like checking the properties of the application, not just the functionality of the application, but they are checking how good the application is performing rather than the normal functionality. And again, performance testing is one of the major non-functional testing. And here what we do is, this is a type of testing to determine the responsiveness or like the throughput or the reliability and scalability of a system or an application under a given load. Again, it may not be under a given load. There are various types of performance testing. The major one you would have heard is like load testing. At times you hear like performance testing or load testing being used as if it's the same. But I would say like load testing is one of the type of performance testing. What do you mean by load testing? In load testing, you are given an application and you know this application is supposed to have like 100 users or like at this peak time or like once you log in or like by noon or sometime, you are expected to have at least 100 or 200 people logging into the system. And the application, like the DB server, app server, everything should work well. It shouldn't exceed like 70 or 80% of the utilization, those kind of things. So it's like under the load, which you are aware of. Okay, this is the maximum load which you are expecting. And stress test is like, as I said earlier, you're trying to see like what is the breaking point? How much can this handle? You know, this is the 1x is the load. Then you'll try to test with 2x, double the load. Sometimes you'll try to do with 3x, triple the load and see, okay, at what point the CPU is like going 90 and above and the system is crashing or like the out of memory error is coming. So we want to know till what load or like at what point it's getting stressed out and the application is going down. Because sometimes even if, you know, the CPU or the utilization is going above 80% in the servers, it will still process the request. It's not that it's completely logging off the user or anything. It will be still processing. Sometimes it will be like very slow. The pages which you are supposed to load by 1 second may be loading in 5 seconds. So that's the kind of stress test. But we'll be trying to see how much it can go and it completely crashes. So what is that point kind of thing? Then comes endurance testing. Endurance testing, yeah, by name such, maybe you can understand. It's like how much you can endure and putting a lot of load in you. Normal load test, let it usually will be like 1 to 2 hours testing. But in case of endurance, we may go from 8 to 12, or some companies really want to do the endurance and they'll say 24 hours, put the load. But again, like those kind of companies will have good infrastructure also. Not every company has it, but yeah. So normally we'll do like 8 to 10 hours of endurance testing. And why we do that is because like some may ask, you have already done the load, because anyways you're using the same load. You have already done the load testing of 2 hours, then why you're doing the endurance testing again? The thing is that some of the times, even if you do a load test, you may not find all the issues. After some 2 or 3 hours or like 4 hours, you may see that garbage collection is not happening properly and the memory is not being released. And finally, you get out of memory error and the system will crash maybe after 5 or 6 hours. So just if you say, I did a load testing 2 to 3 hours, system is working fine, let's deploy in the production. Maybe consider Cyber Monday kind of, because earlier in some of the projects, Cyber Monday was like very hectic days for us, the performance testers, because they know I worked on Nordstrom. We'll do the preparation months earlier because Cyber Monday, and that is the time they are really afraid of all the competitors. They don't want the customers trying to log into your system, and that time you're not able to get the log into the system and go to some other competitor and get all the deals and get the things. So those kind of Cyber Monday time, we'll do like the endurances, because that day you expect the load to be like that kind of whole day. It's not like people will be logging in only for some time and logging off. So endurance is, yeah. Sometimes endurance is also called as soft testing. That is also another word. Then what is spike testing? Spike testing is like you're trying to bombard the system with a lot of load suddenly. In a normal scenario, it's like, okay, in the morning, a normal system will be like slowly the user count will be increasing, then a steady load, and maybe by night, you'll expect the load to decrease. But in case of spike, we are just trying to say, let 100 users hit the system suddenly and see how the system is reacting. So how the memory, how the CPU utilization, all those stuff we are checking. So that is the spike testing. And volume testing, usually we do it for the databases. Like there are some kind of things called like initial load when we are migrating the system, or like putting the data to the database for the first time. So you'll be having like bulk load. So that'll be like a one-time activity maybe you're doing, but still you want to do it and see how the database is performing. So these are the major types of the performance testing types. And the major testing tools, performance testing tools available are, there are like some of them may be using proprietary tools, but the normal ones available, some are like open source and some are like licensed. JMeter, I guess many of you would have heard about. Some use it for like normal API testing also. JMeter we can use for both UI and API testing. Then LoadRunner, that is licensed one. Then NeoLoad from the Tricentis. And Gatling is one which is coming up like slowly into popularity because it uses Scala. So if you are at least aware of Java scripting or Scala, at least Java, it's easy for you to do the scripting in Scala. So many of the folks who are coming from the development field and moving to testing nowadays are trying to use Gatling. And it's easy for people who have the coding background to do the testing in that one. Then you have Blazemeter and Locust are some of them. So you talked about like performance testing. Now you're hearing performance engineering. So what's performance engineering and how is it different from performance tester? Like over the period of time, when I started and all, mainly the expectation was you do the performance testing, give us the results, we'll give it to the development team. Okay, it was good for us also. Okay, we didn't have to do much, do the testing. Here is the result. That's it. But over the period of time, what we have seen is the expectation has changed. It's not like the performance system will do some testing and give it to us, tell us where the problem is or what the problem is, and give us some recommendations. Kind of expectation move to that engineering aspect also a bit. So in the beginning and all, we didn't have all these kind of tools. So maybe if at all we had a like server access and those kind of access was given, we would log into those servers, Linux servers or the Windows server, and check the server logs and try to do the grep command or like with the server like service code, like if it's 503 error or 500 error, and try to see okay what is the issue. And if it's something 400 related, okay, if it's something an issue caused by our data itself and not the application, all those kinds of things we had to do manually. But over the period of time, so many profiling and application monitoring and observability tools came into being, like Dynatrace, AppDynamics, Splunk, Prometheus, and it made our life really easy because like most of the projects they want, and when they market it so well, all the companies wanted to use it, and we have those agents installed in all our servers, and there'll be a main server machine from where like they'll be collecting all the data, and we can create nice dashboards and all the things. And whenever the test is running, we can do the live monitoring. So it was like very helpful because like some cases, if you are using JMeter, I don't know how many would have done the performance testing with JMeter. Even though it has a UI format, we can use it for the scripting and like a smoke test kind of thing. But once you are running the actual load test, we won't run it in the UI format. Usually we'll do in a non-UI format because it takes a lot of memory, and maybe the load generator machine in which you are running itself will go out of memory. So normally we do it in a non-UI mode. But the problem is when you're running the test in a non-UI mode, until and unless the test is over, you won't know whether the test is successful or not. Because like we have to wait because you don't have any window to see. But now that we have all these profiling tools, it's easy. Like we can create give the data to Prometheus, and from there connect it with the Grafana. So even when the test is running in a non-UI mode, we can see in the Grafana dashboards how the test is and how much failure rate, or if something is there, we don't have to wait until endurance test to complete. In between, you can stop and do the necessary things and restart the test again. So those are the profiling tools. Again, like performance testing, as I mentioned, like it has evolved a lot. Like earlier, if it was just the load testing, then like they wanted to have like, again, this is from the internet, I've got this one. It's not exactly the way I wanted, but yeah, kind of it matches. Like over the period of time, they had like the user performance where they came up with the client side performance testing. Because in some of the cases, they'll say, it's okay, we just need to know the performance of API. But in some cases, they'll say, no, we want to see how it is in the UI also, how much time the page is taking to load, how the UI is performing, all those things. So that is something which is happening at the client end, and that is called client-side performance. And then like we incorporated the CI/CD things, Jenkins, and those kind of things into the testing so that we can reduce the manual activities. And then service virtualization, where like we can, in case we don't have all the services ready in the performance environment, we can virtualize some of the services and try to send the data to those kind of downstream systems. Okay, so in the performance testing, these are the major stages or steps. We'll start with the NFR gathering, we'll say non-functional requirement gathering phase, where you'll be talking with the business team or the development team and trying to understand what their requirement, like what is the test requirement. Because in the case of like unlike functional, in the case of non-functional, sometimes they don't know what is their requirement. They just want to know, like they just know that we have to do the load testing. But if we ask them, okay, in how much time the page should load, what is your expectation? As fast as possible. Maybe sometimes that be the kind of answer they give. Some will be like very specific and they'll say a search operation should be done within 1 second. A create or edit operation, it can take until 3 seconds. But some will be like, even we don't know, you test and tell us. And the major thing is like, we need to know, like, what is the user expectation? That is one thing we ask. And in new or like in some cases, again, they'll say, we don't know, maybe roughly 100 users. What do? You just start testing with 50, 100 users and tell us how much it can. There are cases like that. So it's not like always you will get the data from them. So in those kind of scenarios, yeah, again, like we have to go ahead and test and come up with the idea. So the first step is like requirement gathering phase. We'll be having the discussions with various teams and trying to find out, like, again, the major thing is in performance testing, unlike the other automation testing, let's say you have some 100 or 150 use cases or test cases, we won't go ahead and do all the testing. We'll be saying, cut and clear, we'll be doing only the critical, business critical test cases. So even if you give me some 150 use cases, I'll say, out of this, based on the workload and the criticality, if only this 50 to 60 matters, we'll be doing only those. And that is like kind of agreed in the beginning, and all those things we'll put in our performance test plan. And until and unless we get that performance test plan signed off by the client or like whoever it is, we try not to go ahead with the other things so that, both of our expectations should be on the same page. And we try to put in scope and out of scope, because in some of the cases, the thing is that we'll be putting an in scope and somehow they'll think, oh, I thought maybe you'll test that also. So nowadays we clearly put out of scope. All these services, no. Sometimes they'll expect you'll test those downstream systems also. We'll be said, no, no, no. This was the system in scope. So we'll be testing only those. So that is something which we'll say in the first place. Again, another thing which we say to them is like, that's very critical for the performance testing. We say we need functionally stable code, because there have been cases in which functionality itself is like not working. Functional testing team is doing all the functionality testing over there. And that time itself, they'll say, do the performance testing. Because in the performance testing, we are doing scripting and it captures a lot of dynamic data from the code. And if they're keeping on doing the functionality changes itself in the code, we have to do the rescripting. And it's again like a waste of time. So one of the major assumption or like the criteria is like, we say, whatever testing we have to do, give us the functional, even if it's not the very latest one. If you guys are doing the latest one, okay, but give us just the version before that, or whatever it is, it should be functionally stable code. Because there have been cases in which the performance testing team during our testing had found functional issues also. there was a case in one of our project, like we have been doing the API testing for that, because in performance testing, we test with lots of data. Unlike automation testing, where you have like 4 or 5 set of data, we'll have millions of data. And we have done the testing of that API earlier also, but somehow that time we saw that it's exceeding 7 seconds, that API. It never exceeded like that. Usually it will be like within 1 second or 2 seconds. We saw the average response time was 7 seconds. So we are like wondering what happened. We had Splunk for that project. So we went back and checked the Splunk logs, and we found that some two operations, like two data, like two iterations were timing out with they have set the timer as like 120 seconds. So after that, it was timing out. And because of just those two iterations, when they're taking the average, the whole of that API average was exceeding 7 seconds. So we took the data, like which we used for that testing, went back to the dev team and said, for these two data, we don't know, like somehow it is taking this much, but that was the first time we were testing with that data. Then they checked the code and that data, and they were able to find that somehow a check was missing in the code. Ideally, that data, it was supposed to have a dependency, like, okay, which user is having this many number of cases or something. But somehow in that case, that user didn't have any cases. So in the case of 0 cases, they should have done a check in the code if the number of cases is 0. But somehow they missed that. And when we tested that with that data, we were able to find that, okay, that was like a code kind of improvement which they had to do. So in cases like that, sometimes we are able to find the functionality that like that, because ideally the functional team should have done that testing. It's not on us. Like they should have tested with our data which didn't have any cases, kind of thing. So like that, yeah. Next is like once the team signs off and like they say, okay, the plan is fine, you guys can go ahead and do the test. We'll come up with the test scripting part, and we'll script the test, like, yeah, with JMeter or like whatever tools I mentioned, we'll be doing the scripting. And then we'll do the test design. When you say the test design, it's like, even though you have all the scripts, you'll be having like different test plan kind of like work plan kind of thing. Because like, as I said, one for the load test, stress test, endurance test, like that, you'll have different test designs. Once you do the smoke test and think, okay, the scripts are fine, now you move to the test data generation. So that's where it takes a lot of time, because in some of the cases, it's like if you have to run 2 to 3 hours of test, and if it needs unique data, you have to prepare a lot of data for that. So the load test data generation is one of the major area where usually the performance team takes time after the scripting part. Then comes the test environment setup and execution. So again, for performance testing, we'll say, try to give us a isolated performance environment so that even if we test something and if we break something, it is not affecting the other testing teams. If the client is rich enough and they have budget, it's okay, we'll get like that. But in all the cases, it won't be the case. And sometimes we have to share with the other testing teams. So maybe they'll give us a window. This is the time for performance testing, just do in this window. So the test environment setup, and like, again, that is a time when your communication skills also is really important, because like you have to frequently communicate with other teams and ensure that, okay, they're not doing any tests, so that, okay, we can go ahead. Because sometimes the case is like, even though it's our time frame, maybe they will be doing some test. And there have been cases like that. I was doing my performance testing, and I could see that there was like the test manager was sending a mail saying that functional testing or like automation test is failing. Somebody's bombarding the things with data from which server it is coming and all. But I was like, okay, it's not for me, because it's my timing and I'm doing my own test. Later, it was like a big mail chain with everyone. That test manager said, Rini is the culprit. I was like, oh man, he should have written in a different way. Like, because I was just doing a load test. Ideally, it was my time, but somehow they thought they could do the testing that time, and they sent mail saying that, okay, I'm the culprit because I'm doing the testing, and I had to do stop the test that time and let the other team do, because that was critical. But again, like, so ensure that before in case you are doing testing in a like shared environment, ensure that no other team is doing the testing and you're doing. Then comes like once the testing is done, then you'll like during the testing you'll do test monitoring. In the real time itself, you'll do test monitoring with the help of all these tools and see how the test is going. If you're seeing like CPU exceeding 80 to 90% or like memory is going down, all those things. Then finally, you'll generate a test report and share it with the team with all your findings. Like, okay, these are the issues you found. And with the help of all these tools nowadays, like we are able to do good recommendations also. let's say your query is taking this much time. Ideally, you wanted it to be like within 5 seconds or something, and you see that in the Oracle AWR report or somewhere, like you can see it's taking, even a single query is taking more than 12 seconds. If you take the explain plan of that query, you can see maybe an index is missing or like those kind of things. Then maybe you can tell them, okay, maybe if you add an index to that query, it will take less time. So those kind of suggestions you can give. Oh, yeah. Yes. For example, sometimes we are asked to make this performance that in our automation, but they have a much better machine. Yeah. And we can have different software. Yeah. Ideally, yeah, again, like first we'll say try to give us like a performance testing environment with 1:1 ratio, 1:1 ratio, like in production. So in most of the cases, it won't happen. Sometimes what they'll do is like, okay, they can give us test environment, a scaled down test environment. So in some cases, it will be like the hardware configuration could be like 1/4 of the one which is actually in production. So in those kind of scenarios, what we'll do is like the capacity planning. So we'll be doing the load test in our environment, and we'll take the data, and the results we'll tell them. This is based on these server configurations. So ideally, in the production, it should be able to handle more. And again, we'll say like all those things, like if in our system, like in the system where like or the environment where you tested, it had like multiple things running on, like in the background, or like some other processes running. All those things we need to mention and tell that. Based on all these things, we have come up with this results. But in production, if it's running in an isolated environment, we are expecting it to do better. And there is something like the capacity planning, like I don't know whether you have heard about like service demand and those kind of things we can find. I can, yeah, talk later. Like there is an option to do the testing in this one and calculate a value called service demand, which we use and try to predict. Like this is the capacity we are expecting in so and so configuration. Yeah. So based on my, we have some. So based on my experience in performance testing and the recent learning in AI, I've come up with some of the use cases, AI use cases, where I feel performance testing use cases where I feel AI can help. It's not like a perfect 100% perfect solution. It's some areas where I feel, yes, if you have the right knowledge and the right systems and everything in place, maybe we can use it. So the first thing is like creating the test plan. Because when we join, like if you're kind of fresher and if you don't have like a proper set of instructions in your team, because there are some teams in which the only document is in that person's head. No, you don't have any data, any document anywhere. If you are new to the team, it's very hard. I remember like I joined one of the recent client during the COVID time, and the person left 1 week before, and nobody knew. And I was literally begging each and every person for like, do you know? Do you have some info? Do you have some info? They're like, sorry, we don't know. Then I'm like, do you know at least some person who may know that info kind of thing? So sometimes you won't have anything. So maybe you have to come up with the scratch and that kind of thing. So maybe I feel like AI can help in that. Like if you're giving the right prompt and like if you have at least some kind of template or like previous test plan, you can give that as an input and then tell, okay, this is the sample and these are my requirements. Maybe I need to test API or maybe I need to test UI or batches, whatever it is. Try to generate a sample template so that, you know, at least if you are new, if you have something and then maybe you can take it to the next level and get it reviewed or like have the modifications. Then the next thing is like test data generation. As I told, like in load testing and all, we need like lots of data. And earlier, like we used, in some of the projects, we used to like have some VB script or like shell script and generate all this data. But I feel like nowadays, like with AI, just prompt it, zero shot or like single shot or multi shot. If you're doing the right prompting, I think you can get whatever data, because like in case of like create user kind of scenario or a create account kind of scenario, you may need unique users, unlike a get or like search scenario. So in those kind of scenarios, maybe if you can use AI, say like give like a unique first name, last name, address, those kind of things, it should be easy. Then coming up again, like for the test scripting part, as I told, like Gatling, it's very easy if you already have Java or Scala background. Again, if you don't have like, and if you are new to that kind of scripting kind of thing, maybe you can ask, like, if you are given an API and they say, like, we need to have Gatling scripting, you can just provide, this is my URL, and I want you please generate a script to me, Gatling script, with 100 users for this load testing, and this is the response time SLA kind of thing. It can generate the Gatling script, but don't consider it as like 100% perfect. At least you will get a template from there, like you can modify it and do the necessary things according to your project requirement. Then again, like the test report generation, there have been some projects in which they expect us to do tests daily and give a big report. And the worst part is that the managers will be only reading that first summary part. And even though we have to spend hours making that detailed report, only the summary. So I feel that is one place where AI can really help. If once you're doing all the tests and putting it to that and prompting it, okay, here are the test results from the testing tool, give us a report in nice and good format, like however it is, that would be helpful. And these are some of the performance engineering use cases which I have felt. If we can predict the server utilization, if you have like the history of logs, like CPU, memory, and if so many, like disk utilization is also, if it is increasing, so many disk reads and writes happening, maybe we have to add more RAM. So those kind of things, if they can predict the server utilization based on the server utilization metrics, that would be helpful. And again, like the transaction response time is a key thing. Like in case of performance, like the SLA, the major SLAs, they'll give us like, okay, this URL or like this transaction should be done within 3 seconds or like 2 seconds. So that response time is one thing. So in case like earlier I told, like if there are some outliers, like all the others will be doing good, but if at all some 2 or 3 transactions are doing bad, it'll affect the whole average response time. So you can find those kind of outliers with the help of this one. And again, like the load, like I said, like a holiday event or like anniversary sales, based on the previous year's events and that log, if you can give that as input and if you can kind of forecast so that, it'll be easy. Nowadays, again, like it's much more easy because like most of them are doing the testing in Docker or some container environment. And you have the option of like giving an auto scaling option. So we can just give a number like, okay, if it's a minimum is 3, if the load is going much above, like we can set the conditions. Like if it's like 70% above the threshold or something, scale 3 more containers and distribute the load. But earlier it was like we have fixed set of physical servers. There it was difficult. So you have to, kind of see how the earlier was and then try to test with 2x or 3x load and kind of be happy, like, okay, hopefully we do well in the production during a holiday season kind of thing. And these are some of the currently available AI testing tools I've seen based on my research, but these are not like exactly performance testing tools, I would say, mostly like automation and UI kind of thing. As of now, I haven't seen any performance testing tool as such saying like AI with AI data, like AI is there. So these are some of the tools which I've seen. And like these are potential AI solutions which I feel like based on the functional models, like I mentioned, like Amazon, like they all have like various models. And maybe we can use like Amazon Titan or like Google Gemini and OpenAI for use cases like test plan creation, test data, and test report. And we have like Google Gemini again, like for code generation for the Gatling scripts or like JMeter scripts, Mistral AI, all these we can use for the code generation. And we have like image generation models like OpenAI's DALL-E or like Stable Diffusion's Excel. Those we can maybe use to have like when you generate the test report kind of thing, if you want to have like a graphical uh, format or like some nice pictures so that, once you're taking it to business or like higher level, they are interested in pictures so that they can use it for their higher level managers and they won't be so much interested in the technical part. So those kind of scenarios, maybe you can try to use these things. And again, like the artificial neural network or like the deep learning techniques, I feel we can use for the performance engineering aspects like predicting server utilization or like forecasting and detecting anomalies. So this is something which I have done like just for my own. You guys can like think like just have this and expand on like however you want. This is just a performance test report, like a very basic report I tried to create. And I use like Google model like Gemini 1.0 Pro. So as you can see here, like I've given some safety settings also because in AI, again, like good and bad aspects are there. So the prompt which you are giving, if it's like some kind of harm is there, we can like block those kind of things so that, it will say it's not kind of, what to say, it's not meeting the safety requirements and we can't generate the output for these kind of things. So there we have like various options like medium level, low level, and high level. So here I've blocked medium and above kind of like safety issues kind of thing. Here, what I've done is a test result CSV is an output file I've got as part of a load test I've done in JMeter. And I've tried to give that. And here you can see the CSV file will be like this. We'll be having the time frame, the API which you tested, the response code, whether it is 200 or not, and what is the response time, and all those details that you give. Ideally, in a normal case, like we have to go through all this and come up with a report and data. And here, what I've done is like I've asked the model to create a performance test summary report with findings and recommendations based on the data in this result file. This is like a very high level thing. It just created me. But rather than me going to each of the things, it just gave me all the results. Like, okay, you ran like 100 transactions, and these were the transaction response time with the average, median, 99 percentile, all the things. And it gave me the utilization and some of the findings. And it even gave me some of the recommendations. So this is like a very high level thing which I've done, but I've tried to do it for some. Oh, sorry. I've kept that in my Git repo. I can share that also. So there I have tried to do like some 4 other use cases also, like test data generation and test plan generation. So we can check that also. Again, like even though you say AI is too good and with AI you can do many things, there are some factors to consider. Major one is like hallucination. I think like most of you would have heard like many of the speakers talking about the AI, like the model hallucination. So that's like, yeah, even though we are training the AI models with all the required data, it need not be perfect. And the output it generate, it can be like false or like inaccurate. And this can lead to mistakes and there can be some risks. I don't know like how many of you have heard about like false negatives or like false positives in the AI problem. False negatives are like more worse than the false positives. Let's say based on some AI model, you try to like give some data and ask it to tell me whether it's positive or negative. Actually, if it's positive, let's say a cancer detection kind of thing, you gave the results and that model went through it and said, oh, you are negative. But in reality, if it's positive, it's giving you a false negative kind of thing. So that is more critical than it's saying like even if you don't have, it's saying you have, but once you do the test, it's like, okay, I don't have. That is kind of okay compared to the other one. So that false negatives and false positive. Again, like integration, when you're integrating with the system, it need not be like all the companies or all the applications are in very good state so that you can just plug in AI and next day it will work. There will be so many legacy applications and like systems we don't know like in whose age they got that server. So those kind of applications will be there which are not at all upgraded. So you have to like see like based on your requirement and your systems, either you upgrade the systems and then try for the AI part. First you do the basics right and then you try to put AI on top of that. So those are some kind of scenarios which you have to take based on your project. Again, the model choice, like nowadays, like a lot of foundational models are there and everybody is marketing like anything. So just see like experiment with it and see which one is like doing good for you, because sometimes some of the things are good for like image generation or like data generation, code generation, but it need not be good for your specific case. So just try around and see. Again, the major thing is like computational resources. When you say AI, of course it's good, but it doesn't come without any cost. If you are doing like with lots of data and lots of processing are involved, you may need not just the normal CPUs, you may need GPUs. So that definitely your company needs to have the budget for that. So all those things you have to take into consideration. Again, another thing is like responsible AI. Since I use the Google Gemini, I've tried to use some of the responsible AI principles by Google. As you can see, like be socially beneficial. That's the major thing everybody has been trying to ask yesterday and see how it doesn't go to bad people or like how it can be only used for the good things. Yes, for this thing, what we are trying to achieve is like for the software testing professionals to benefit for them and to reduce the time and effort. And again, like we have to be testing it for the safety also. As I've mentioned, like there are some options to block the harmful contents. And again, based on your project requirements, like you can set that high, low, medium level, and at least ensure that, okay, it's not generating something harmful to your team or like general. Again, like even though it's all AI, you have to be accountable to people also. It's not like AI knows everything. The AI model is only as good as the data you have fed into that. If your data itself is bad, even though the model is trained in all that, the output it's giving need not be as correct as that. So take into consideration those people who are like technically good in those kind of things. And even though it's generating something, get it reviewed by them and see, okay, these are the suggestions and incorporate those also. Okay, my final closing reflection will be like, even though AI is like very transformative and like it has all the power, and we have to like keep up with the, fast-paced technology. It's like within 1 or 2 weeks, it's like, okay, today I've been learning about this technology. Okay, now Docker, now container, now AI, foundation model, those. So kind of you have to, keep up with all those technology also. You have to keep on learning. And you have to see, like, again, like incorporate them, like wherever you can feel like, okay, it'll be improving your testing efficiency. And again, like one of the major thing what I felt is like all the manual time consuming activities with the help of AI, maybe we can convert and use some automation with the help of this AI and try to have some predictive insights rather than, doing the normal thing, some kind of prediction or like forecasting kind of thing. And yeah, to sum up, if there are some individuals or at least teams with some kind of a foresight, they can utilize AI and ML to enhance their performance testing process. And rather than a reactive strategy, they can be to move to a proactive strategy. Like they don't have to wait until something breaks in the production and then start all over. But if you have like having like, okay, the systems in place, like monitoring or all those things actively in place, that'll be a better option. Yeah, if you want to connect, these are my options, and that's it pretty much. If you have anything.